In this section, we're going to look at some more derivative rules, and it's going to get a little bit more and more complicated as we learn more rules. Rule number 7 is called product rule, and product rule is when you have two functions that are multiplied together, therefore the product. So let's say that you have two functions f and g, so f of x and g of x, and then you want to differentiate this function with respect to x. Then what you're going to do is you're going to take the first function and don't do anything about it, and then multiply by the derivative of the second function plus the second function, so don't do anything about it, and then times the derivative of the first one. That's it. So pretty simple stuff. When you have two functions, so remember it's two functions, the functions are both in terms of x, multiply together, then what you're going to do is take the first function times the derivative of the second one plus the second one times the derivative of the first one. So for example, the following question, y equals 2x times 6x plus 1. So you can think of it as two functions. So let's just call it box and triangle. So two functions, they are both in terms of x. Then the derivative is, let's just write it in box and triangle. So box d triangle plus triangle d box. Okay, so box is 2x. The derivative of triangle is 6 plus triangle times derivative of box. And then you want to just simplify as much as you can. So 12x plus 12x plus 2. Oops. That is 24x plus 2. All right, let's look at another one. So again, we have two functions, both of them in terms of x multiplied by each other. So if you want to find the derivative, you would do box times triangle prime, or derivative of triangle, plus triangle times box prime. So go ahead and give this one a try and then come back and check your answer. So go ahead and check your answer. This is the derivative of the function f. All right, let's see. Let's have you try number 2. All right, so again, the analogy with box and triangle. So x d e to the x. Remember, the derivative of e to the x is e to the x. That's why we don't change it. Plus plus triangle. Triangle in this case is e to the x, and then the derivative of x is 1. And then what we want to do is simplify it. So take out the e to the x, and then you have e to the x times x plus 1. Now let's go ahead and try number 3. This time you have to evaluate as well. All right, you can go ahead and double check your answer. So let me talk about a simple mistake that I've seen students do before. So the question says, what is the derivative of 2? So some students, they would plug in 2 into the function first, like so, and then take the derivative. This makes no sense because if you plug in a number first, you're basically saying you're finding the y value at that, right? This is just the y value at x equals 2. And then you're saying what is the derivative of that number? Well, I mean, no matter what you do, it's always 0. And so this doesn't make any sense, and it is not the way to do it. What you're trying to do is you're asking the question, what is the slope at x equals 2 of the function? And so you cannot put in a number and then differentiate. You're always going to get 0. So that doesn't make any sense. And then let me talk about another thing. So this happens a lot. So f of x, let's make it really simple. 2x. Let's say 2x squared. So then, after I teach the product rule, this happens a lot. People start seeing this 2 as one function and this as another function, and they start doing product rule. which is fine. Product rule can take that, but you're just wasting time. 2 is not a function, right? 2 is just a number. There's no x in there. So if you do use product rule, so for example, if you use product rule, you would get 2 times 2x plus x squared times the derivative of 2 is 0. So then you end up with 4x, which is the same if you just did power rule, right? Power rule is just 4x. So you're just wasting a lot of time by making a constant into a function. So please don't do that. All right, rule number 8 is the quotient rule. So quotient rule is when two functions are in quotient, I guess, to each other. So that means you have a function divided by a function. So the previous one was product. Product means multiply. Now we're doing quotient. So if we want to take the derivative of a quotient of functions, then what we're going to do is remember this rule. Well, before you remember this rule, I need to tell you the little chant. So it's low d high minus high d low all over low squared. Okay, so if you're at home, make sure you say it with me, because if you don't say it with me, this is a very hard rule to remember. Low d high minus high d low all over low squared. Okay, let's try again. Low d high minus high d low all over low squared. Okay, so here's how it works. Low means the lower of the two. So, when you have a quotient that's a fraction, so it's the lower of the two. So low d high, so d derivative of the higher one, minus, let me put the chat there so we can see it, high d low, high d low, so derivative of the low, all over low squared. Okay, please do say it, because if you don't say it, you're not going to remember. Low d high minus high d low all over low squared. All right, let's look at an example. So let's look at this one. Find the derivative of the following. Number 1, you have a quotient rule, function over function. So the derivative is low d high minus high d low all over low squared. Okay, so low, oops, d high minus high d low all over low squared. Okay, and from here we want to just simplify as much as possible. This is basically algebra from this point on. Please don't make any small algebra mistakes, or I will also try not to make small algebra mistakes. So this is 10x squared minus 4x all over squared. All right, so we are going to FOIL. Please don't distribute the square. So this is x to the 4th. Actually, you know what? Let's leave it as is, just in case there's a factor I can cancel. We'll see. Okay, 5x squared plus 5 minus 10x squared plus 4x over x squared plus 1 squared. Okay, simplify that. Minus x squared, 5x squared, sorry, plus 4x plus 5 all over x squared plus 1 squared. Doesn't look like there's anything, doesn't look like the numerator can be factored, so that's it. All right, this one, quotient rule. So now let me ask you, should we use quotient rule on this one? Definitely not, right? You see the 9 in the numerator, that is not really a function of x. That's just a constant. If you use quotient rule, it will work, but it's a waste of time. This one is easier to do if you were just to change it into power rule. So this is really just 9/5 x to the -2. And it's very easy to just take the derivative by using power rule. And so this is -18 over 5x cubed. So much easier to do. You don't need to waste your time for this kind of problem on quotient rule. So make sure you do recognize when you should use quotient rule and when you should use some other rule so it's faster. All right. Number 3, let's go ahead and have you pause the video and give this a try. Remember, it's low d high minus high d low all over low squared. All right, here is the answer for this question. Now that we're more familiar with product rule and quotient rule, let's apply to something that's kind of more out there, I guess. So let y equal uv. That's the function, the product of the function u and v. Find y prime of 2 if, and then you have all these things. Well, they tell you that u and v are functions, and so if you were to find the derivative of y, then since this is a product between two functions, you're going to have to use product rule. So u v prime plus v u prime. So product rule, you're going to add, the rule is an adding in between, and then quotient rule is a minus in between, so be careful of that. Of 2, so then that means every one of those functions and their derivatives is, all this is evaluated at 2. And it's nice because they tell you what the numbers are. So u of 2, it says is 3. V prime of 2 is -4, plus v of 2 is 1, and u prime of 2 is 2. So this is a very easy problem, just wanted to see if you understand product rule. Let's look at this one. This is a crazy problem. So how would you find the derivative? What do you guys think? So we have 3 functions now, right? 1, 2, and I don't know, circle 3. And so we basically have a product over another function. So basically we have a product rule and a quotient rule. So you can either do a product rule and then quotient rule, or you could maybe, I don't know if this is simpler, you can FOIL the top so then it becomes one gigantic function, and then you can do a quotient rule. So either one, give it a try. Please follow the I guess the same logic. So maybe I'll start it for you. So basically, if we're trying to find the derivative of this one, so if we're trying to find the derivative of this whole thing, we would say we would have to treat it as one big thing over something else. So we'll have to think of it as a quotient rule. So I'm going to keep it with box and triangle for now, and then so you can see the logic behind this. Okay, so if it's a quotient rule, then we're going to do low d high minus high d low all over low squared. Now, what's going to happen in this part? D box. What's in D box? The box is, again, of, oops, 2 functions. So then when you're saying D box, you're basically saying take the derivative of the box. Well, taking the derivative of the box is going to require a product rule. So then there is a product rule inside this box prime that you will have to take care of as well. Do you guys think you can give it a try? So go ahead and try it and then come back and check my answer. All right, this is a crazy problem, doing it with quotient rule and then product rule, but after doing the whole thing, this is the answer, 3 over x to the 4th. All right, the next one, find the derivative using the values given below. So given that h is f over g, find h prime. So this is very obvious they want you to use quotient rule. So Okay, again, differentiate first before you put in a 3. So low D high, oops, minus high D low, O over low squared. All right, and then everything is evaluated at 3, so we can just figure out all of the function and derivative at 3. So g of 3 is this one, 2, and then f prime of 3 is -1, minus f of 3 is 1. G prime of 3 is 1, all over g of 3 squared. So this is -2 minus 1 over 4, which is -3/4. All right, let's have you try. Given m is f times g, find m prime of 3. Okay, the answer is -1.